It's time for another Mr. Nickell's Science video.
Hey everybody, welcome to another Mr. Nickell's Science video. Today, I'm going to show you how to make what I call a rocket balloon. But first, I have something to show you. This balloon here, when I let it go, does this. All right, it went up. This balloon here, when I let it go, it does this. It went down. One went up, one went down. So take a moment to think about it. If you need to pause the video, go ahead and pause it. Why would one go up and one go down? All right, you ready? The answer is relative density. If you answered buoyancy, that's also correct, but we're going to focus on relative density today. So because of relative density, one went up and one went down. Now, think about it. If the red one went up, relative to the air around us, would it be more or less dense than the air that's around us when it went up, the red balloon? Think about it. Pause the video if you need to. Ready? The answer is less dense. That red balloon above me now is less dense than the air around us. So its total density, combined with the helium that's inside, because the helium is much less dense than air, and the shell of the balloon, which is latex, which is actually more dense than air, all of that combined together is less dense than the air around us. Obviously, then the blue balloon would be what? That's right, more dense than the air around us, because it's filled with just regular atmospheric air, and it's got the density of the actual latex shroud around it, which means the total density now is greater than air, or more dense than the air around us, and it fell. Now, what about this balloon? It's not going up or down. It's just hovering in place. I can actually play with it back and forth and have it just move about. So what's the deal there? Not up or down. So what does that mean? Take a moment to think about it. Are you ready? The answer is it is neutrally buoyant, or in other words, it is the exact same density as the air that's around us. Now, obviously the helium is less dense than the air around us. The balloon itself is more dense than the air around us, but I've used a trick here. I have included several layers of what's called painter's tape. Now, the painter's tape is more dense than air. If I let it go, you can see it falls. The balloon itself, just a regular latex balloon, is more dense than air, but the helium inside is less dense. So all of those densities combined in this balloon cause this to be neutrally buoyant, or about the same density as the air around us, causing it to hover in place and not want to go up or down. That is the trick to making a rocket balloon. I'll cover more about density in another video soon, but I'm going to show you today how to make a rocket balloon. Are you ready? Here we go. All right, here we go. To make a rocket balloon, there's a couple of steps, and there's a reason for each of these steps, so make sure you follow them carefully. Let's go with, what color do you think I should use? I think you're right. I think we should use pink. That works perfect. All right, here we go. So we got our pink balloon. Now these are those type of balloons that you use, a balloon animal type of dude. They fold them up, dogs, puppies, bunny rabbits, all that kind of stuff. It's those kind of balloons, long and skinny. That's how we're gonna make it into a rocket. Now the problem is, if I just fill this up with helium, it doesn't fill up with enough volume. So even with the entire mass of the latex balloon, the volume to mass ratio is not right, and it's going to sink. So there's no way for me to add any more volume without making it pop, and it's going to just sink no matter what. So I need to get it to where it will float, so then I can add tape to then balance it myself so that it is neutrally dense. In other words, the exact same density as the air around us. The problem is, I got to stretch it first, and I don't want to waste my helium stretching it. So what I do is I stretch it myself, like so, to stretch out the latex a little bit. Then I take an air pump with just regular atmospheric air. I place it on, and I go ahead and pump it up. What this does is it's going to stretch the latex, allowing the latex to later take more volume. And I take it I can feel it as getting real tight. You don't want to pop it. You can very easily pop this if you put too much in. You stretch it, and then you want to go ahead and let it out, and then do it again. Because what this does is it's allowing the latex to kind of relax or stretch out. Those bonds between the atoms and the latex are kind of pulling apart, and allows the latex to stretch and hold more volume. As you'll notice, it looks a little thicker than it did before. And this time I push it right up to the point where I feel like it's just about to pop, but try not to pop it. All right, a little more. And then we let it out again. Now, as you can see, it looks bigger than it did before. It has stretched out. Now it can hold more volume, and now our volume to mass ratio with the helium can be correct. So now what I do is I take it and I fill it up with helium gas, which helium gas is it more or less dense than the air around us. If you said less, you're right. That's why helium floats in air, because it's less dense. So I go ahead and fill it up, and I try to fill it up as much as it'll go without popping. Sometimes you gotta risk it for the biscuit a little bit. Now I've got it to where it is almost completely full. But what I've done is I've pinched this in so that it left me a little bit of latex right here to play with, so I can still tie it, because you want to seal it off. Obviously you don't want the helium gas to escape. So stretch it out, stretch it around. This is the hard part right here. To keep from popping it is not easy. So here we go. See if I can do it. Wish me luck. Tuck it in place. Come on. Don't give up. And I got it. Look at that. Now, here's the moment of truth. If it floats, we can make a rocket balloon. If it doesn't float, we didn't get enough gas and stretch out this balloon enough to turn it into a rocket balloon. So now I'm going to go ahead and let it go. Moment of truth. Here we go. If it goes up, perfect. You want it to go up. Don't worry. We can fix that by adding small amounts of tape. I have painter's tape here. You could use masking tape. It doesn't matter. Try not to use a tape that's maybe sharp on the edges, because you probably will pop your balloon. I use this painter's tape because it's easy. Okay. Couple lessons we learned there. Number one, eye protection, smart. Ear protection, also smart. So please, if you're going to do the experiment, make sure you protect your eyes as well as your ears. Lesson learned there. And one other lesson we learned is it would probably be wise if you fill it up with atmospheric air with your first pump 3 times instead of 2. That would probably be wise. But where was I? Here we go. It floats, which is good, because now what we can do is we can add tape to add mass to our rocket balloon. Because we're adding mass to our rocket balloon, we are going to increase the mass. The volume stays the same, which means its overall density increases, which is going to keep it from floating up and away from us. It's going to make it the same density as the air, which is what we want. So, one thing you probably should do too is find the balance point. You want to put because one end will want to go up. If you want it to stay level in the air, you see one end wants to go up. Finding the balance point by simply moving your finger until it stays balanced. Right. I think I'm finding it right there. All right, that's where I want to apply my tape, because now when it flies through the air, it's going to stay nice and balanced. All right, here we go. Oh goodness, I lost my spot. Perfect, right there. Now hold it with your finger so you don't lose your spot. It would be wise if you have already actually cut several pieces. Okay, little pro tip for you guys. It's really wise to go ahead and have your small pieces of tape already cut. That way you don't have to smash your balloon into your table. Just a little tip for you there. All right, so now we have our balloon that is less dense than the air around us because it goes up, and we want to make it neutrally dense. So we find our balance point with our new balloon. Got it right there. I mark it with my pre-torn or pre-cut pieces of tape. I go ahead and lay them on carefully. Remember, no sharp edges with your tape. And then I test it. Where are we at? Still going up, which means we need to add density. add mass, which will increase our density. So to balance it out, I'm gonna put it on a different location on right there. Let's just see about my balance point, and we're getting closer. Now, as you'll notice, this end right here is going up, which means I need to come down with my tape a little bit to balance things out a little bit more. So let me put this on here. You see I came down a little bit to try to balance things out. And now let's see. Still going up, which means I need more tape. I should have pre-cut more tape. Luckily, I had some leftover pieces over here because I do not want to smash this balloon into the table again. All right, still listing up, so I'm going to come down this way with it a little bit. Adding more mass to my balloon. Ooh, now look what's happening. And there you have it. A neutrally buoyant or neutrally dense rocket balloon. And here's how they work. Check it out.
0, 1, 2, 3. Let's get started.
Oh, that's real good.
All right, so there you have it. How to make a rocket balloon that is neutrally dense. In other words, it was not more or less dense than air. It is actually the exact same density as air. And because of that, you can make a rocket balloon that will glide through the air as straight as an arrow without rising or falling. Hope you enjoyed it. See you on the next one.